Hello everyone. My name is Chahat Tandon and my friend Sanjana Revankar are going to take you through the world of text analytics in the most basic way possible. Let's start by some fundamental concepts, shall we? Text mining terminologies. The first is document or a sentence. About 100 years ago, a prince lived in his castle with his family and ruled his kingdom wisely. No, this is not a story. This is the part of a document, or we may call it as a sentence. Second is tokens or words. Tokens represent words. Nation, liberty, men are all examples of words. Terms represent single words or multi-words. Single words such as a woman, civil or multiple words such as civil war, battle cry, flag stop, etc. Corpus is a collection of documents or database. For example, a corpus contains 16 documents, that is, 16 text files. Stop words. Stop words are basically a set of commonly used words which you want to exclude while analyzing texts. It can be a, and, the, to, of, ABC company, etc. Just unimportant words. Document term matrix. It is a matrix consisting of documents in rows and in terms of columns. As you can see, there is row of documents and column of data, results, statistic, and analysis. Sparse terms. Terms occurring only in a very few documents or sentences are termed as sparse terms. Tokenization. Tokenization is the process of replacing sensitive data with unique identification symbols that retain all the essential information about the data without compromising its security. Like your payment from your phone to the bank is an example of tokenization. Stemming. Interesting, interest, interested are all examples of interest and are all stemmed together. After all, we can stem them back to their original form so that the words would look exactly the same. Polarity. Whether a document or sentence is positive, negative, or neutral is based on its polarity. This term is commonly used as sentiment analysis. Bag of words. Each sentence or document is a bag of words ignoring grammar or even word order. The terms Make India and India Make are exactly the same. Parts of speech tagging. It involves tagging each word in the document and assigns part of speech such as noun, verb, adjective, pronoun, single noun, plural noun, etc. Now let's have a look at term frequency, inverse document frequency, TF-IDF. Term frequency counts how many times a word has occurred. Term frequency measures how frequently a word or a term occurs in a document. It is the number of times term T appears divided by total number of terms. Inverse document frequency. It measures how important a word is. If a word appears frequently in a document, then it should be important and we should give that word a higher score. But if a word appears in too many other documents, it's probably not a unique identifier. Therefore, we should assign a lower score to that word. Log to base E, that is total number of documents divided by number of documents containing the term T. Now, let's have a look at term frequency inverse document frequency. It is term frequency into inverse document frequency. Some uses of TF-IDF are building stop words, important words, or text clustering. Let's have a look at an example. Here, doc A and doc B consist of two sentences. The cat sat on my face and the dog sat on my bed. We split the data and import pandas file and showcase it as a data frame as how many times a word is appeared in a sentence. In doc A, the cat sat on my face are all ones, and similarly in doc B, the dog sat on my bed are all ones. We compute the term frequency and we compute the inverse document frequency. Finally, we combine them, multiply them, and find out the TF-IDF. The output would look something like this. Let's summarize what we have learned so far. TF-IDF stands for term frequency, inverse document frequency. It is a way to measure information retrieval or summarization. TF-IDF reflects the importance of a term in a given document. Here's an exercise for you. I hope you will do this and submit your answers in the comments below. Thank you.
Hey there, myself Sanjana Revankar. I'll be explaining about topic modeling and t-SNE. Okay, let's get started. Topic modeling. So, what is topic modeling? Is it something related to topics? Yes, it is. See, topic modeling is a unsupervised machine learning technique. Here, unsupervised means something that doesn't require to be trained. And you know what this technique does? Let's see. First of all, it scans one or more documents and detects words, phrases, and patterns in it. Then it just clusters those related words into topics or groups which has similar expressions which best categorize your documents. Let's and since it is unsupervised, it becomes quick and easy way to analyze your documents. Now let's see how exactly it works. See here in the picture of document and topics. Here in document you see some words are highlighted in pink, blue, yellow, etc. The words in some the words in same color belongs to particular group. Okay, my favorite color is yellow, so let me read the contents in yellow. It has gene, DNA, genetic. So these are the words which will belong to something like genetic material. So these are grouped into one, and same goes to the other colors. Next, at right side, you see the process of topic modeling. It, it is the process of dividing a corpus of documents into two. Here, the corpus is nothing but the collection of similar documents or documents belonging to the same group. First of all, it makes a list of topics covered by that document of that corpus. Then, uh, it, it groups the documents of corpus into the topic they cover. Yeah. So let's get into the uses of this technique. It discovers the hidden topical patterns in that collection, comments the documents according to their topics, and uses these comments to search or organize or summarize the text. You know, this topic can also be used as a text miner to obtain recurring patterns. So now let's learn about t-SNE. It is t-SNE. First, let me give its abbreviation that t-SNE stands for T-distribution stochastic neighbor embedding. Here, I'll be explaining about t-SNE and its working in simple words. Chalo, let's get started. Suppose you have high dimensional data. Okay, it's not easy to analyze it, right? So t-SNE use t-SNE. T-SNE is a non-linear technique for dimensional reduction. You see the image, it has a letter S. It is the example for non-linear dimensional. So, and dimensionality reduction is nothing but reducing the dimension from high level to low level. And t-SNE is well suited for visualization of high dimensional data sets and data exploration, and of course it is a unsupervised algorithm. Now let's look at its working. So this is a simple example I have considered. The left side figure is a input and the right side is the output. See, the points are nothing but the data points. First of all, t-SNE measures the distance or the similarity between the two data points, and it does with every point in the input. Then it converts that similarity into joint probability, and it considers normal distribution for this. Then it arranges all the data points randomly in low dimension, let's say 2D. After arranging, again it calculates the similarity and assigns probability, but this time it considers the distribution. Maybe that's why it is called t-SNE but not SNE. Then it compares both the values, and at final we get is a low dimensional data points which tries to capture complex relationship between the data points. Next, now look at the practical example, that's visualization of iris dataset. This full code you will get in our GitHub blog. Link will be in the description. So let's start. First, you have to import some libraries like pandas, load iris, t-SNE, and some access 3D and all. Then next, load iris dataset. First few lines of the dataset is displayed here. So basically, it contains sepal data, sepal length, sepal width, petal width, and species. The iris is a flowering plant. Okay, I'm not talking about eye iris. In the right side, you can see the 2D graph which is plotted between sepal width and length. It is and its data points. Here, look at the graph after plotting, after using the t-SNE. You can compare the graph here. The clusters are created, right? Compare this graph with this graph, you can see the difference, and the left side one is the 3D, the same in 3-dimensional. So this is how it works. Let's see where t-SNE is used. Climate research, computer security, bioinformatics, music analysis, maybe in music analysis, sound processing, sound analyzing, investigation. It also processes image and biomedical signaling. Okay, this is the brief summary of TD, TF-IDF, topic modeling, and t-SNE. So you can go through it, and that's all, folks. Thank you. Happy learning.